Alright, so we're going to be doing a quiz tomorrow over all the topics that we've been talking about since classes started back about a week ago. So let's jump into it. I'm only going to do like number 1, you do number 2 kind of thing. So come in tomorrow with all of them attempted. Do your best. If you have any idea how you think the process should work, definitely attempt all the problems, okay? So the first thing I notice on number 1 and number 2 is we've got some distribution. So I'm going to start by rewriting the left side, and I'm going to distribute on the right, negative 8 times 1 is negative 8, and negative 8 times 6 is negative 48 with the x on it. So now I've set up my problem using distribution, and I don't have any like terms on the left, and I don't have any like terms on the right. The like terms are on opposite sides, so they need to move. So I see that 6x and 48x, those are like terms. So I'm going to move 48, I'm going to move that to the left. It's really negative 48, but you know what I mean. I'm going to do opposites. Inverse of subtraction is addition. So that cancels on this side, but you have to do everything evenly on both sides. And if you put this together, you should get 42x. Now, if you want, you can rewrite the rest of it to keep everything nice and neat. And now let's do the opposite. Let's put 34 and negative 8 together. But never move the number that's alone. Okay, try to move the number that is with the x, because you're trying to move away from x, honestly. And so now that gives me 42x equal to negative 42. So this looks like it's going to end up being a pretty nice answer here. Let's divide by 42, and you get negative 1. So what that means is if you were to plug in negative 1, like if I was to say negative 6 times negative 1, well, that's positive 6. Excuse me. And 6 plus 34 is 40. Well, you would get the same 40 if you put it over here. 1 plus 6 times negative 1, that's really negative 5. And negative 8 times negative 5 is positive 40. So negative 1 makes both of the sides equal. So you try number 2, and we'll check your work tomorrow. That one's a little longer because you have some distribution not only on the left, but also on the right, and you may have to combine more like terms for a problem that's longer like that. So let's do an inequality. I'll do the one on the left, you do the one on the right. So I see distribution again. That's negative k plus 4 less than 2. I want to subtract 4. That gives me negative k less than negative 2. And this is not quite solved for. I need to divide or multiply, really, negative 1 to the other side. And something that we really have been stressing is with inequalities, anytime you multiply or divide a negative, that rule comes into play. And so it's no longer less than, it's greater than. So I'm going to go into my graph, and I'm going to say all values that are strictly greater than 2. So that number is not included. You can draw it here. It doesn't really matter. Either way, I just like to draw it above the line because in pencil or pen, sometimes you can't see which way you drew it when you just do it on the axis. So any value strictly greater than 2 would be fine for that. So you try number 4. And let's do some compound inequalities. Compound, like if you took that in chemistry, compound would be like 2 or more elements forming a bond. And so we kind of have that situation going on here. We have 2 inequality symbols. So that can be kind of intimidating at first. But as long as we understand that we're working out of the middle to get that n alone in the middle, then we just need to treat every side the same. So I think I'm going to start by subtracting that 5, not only to the left, but also to the right. So that negative 31 minus 5 is now negative 36. It's less than negative 6n, and it's less than or equal to 0. So now that 6 is multiplying, so I'm going to divide by negative 6 into both parts. But just like that other problem we worked on, the negative division is going to change all your signs. So this is positive 6. Instead of a less than, I'm going to change it to greater than. N. Flip that less than to greater than or equal. And 0 divided by negative 6 is 0. Now later we'll talk about you can't divide by 0, but you can take 0 and divide by another number. That's no problem. So basically n is trapped between 6 and 0. So 0 is or equal, so I'm going to fill that point in. And 6 is not, so I'm going to open that up. And basically any value in between them is the solution. So now I'm going to do an OR problem with you. And these problems are kind of separated for you. You just have to work each one separately. So I'll start by writing this problem a little closer to my space. So I see that it's a two-step problem. Not too bad if you're familiar with solving. Let's add 5 over. You get 7r greater than 56. Let's divide the 7 to the other side. And this won't flip the sign because you didn't divide by a negative. So some students think you're always flipping the sign, and it's not really true. So in one case, all values greater than 8 are part of the solution. Well, now I have this other problem I need to work. 10 minus 3r is greater than or equal to negative 8. So let's move the 10, that's the like term, from the left to the right. Yeah, go for it. I get negative 8 minus 10 to be negative 18. But when I divide this negative 3 over, now that rule does come into play, and it's less than or equal to 6. So while I had greater than or equal to 8, it could be also or 6 included, filled in, going left, less than. So notice two things about this section. The top two problems 5 and 6, those are both compound inequalities that are and. Like n is greater than 0 and it's less than 6. So it creates this trap on the graph. But OR problems, they go in opposite directions a lot of times when you're talking about the graph, like left of 6 or right of 8. So those graphs should look similar when you do 6 and 8. All right, so I'm going to let you do this one because I'm curious what everybody does. I'll give you a hint. Start with distribution and then combine like terms. Don't do opposites though. Like if you are adding, don't change it to subtraction to combine a like term. That's more for solving. And I will talk about 10 for a minute because we're trying to get t by itself. So I'm targeting t in that parenthesis and everything around it, the p, the 1, the r, it all needs to move to the opposite side. Now we are solving, so we do use opposites for number 10. You don't use that for number 9 because the directions are simplified. So let's start by seeing that p could divide immediately to the other side. So a divides by p, and that gives you 1 plus rt. All right, so now I want to move the 1, so I'm going to subtract 1 from both sides. Get some space over here, a over p minus 1, and that equals that rt. So slowly getting t by itself. And now I'm sure you're probably knowing that r and t are against each other, which means multiplication. So the last thing I need to do is to divide everything by r. Okay. So tomorrow I'll talk about how you can simplify this a little bit, because in Algebra 2 we talk about how this is a complex fraction. It's complex because you have a fraction within a fraction. And so we can do a little bit to clean that up. But for right now, I think that would be fine. So if you didn't finish the domain and range questions, make sure you finish that too, because in class I'm going to be looking at both. And come in a few minutes early if you have some questions, and I'll be more than happy to help you with that. All right, good luck, and I'll see you tomorrow.